Okay, so special cases, video number 2. Okay, so sometimes the special case will be a little harder to detect. In the other one, there were only 2 terms, but now we have 3 terms. Okay, so the first thing we want to do is say, can we factor anything out of this, right? Can I factor a 3 out or a 9? I can factor a 3 out of a 9. I can factor a 3 out of 24, but I can't out of 16. I can't factor a 9 out of either of those, so there's no GCF, okay? So I'm stuck factoring this. So this is identical, okay? Identical to the stuff from week 5, okay, which was the A5 IXL stuff, week 5, okay, the stuff we did last week. This is the same problem, okay? So you can go about this the same way. You can do step 1, A times C, which is 9 times 16. And then we can say, what are factors of 9 times 16, right? Which we know is 144, right? What are factors of 144, which add to B, which we know is 24. So if we run through our factors of 144, we know 2 of them are 9 and 16, right? And you might know that 144 is a perfect square. It's 12 times 12. If you don't, you'd have to figure it out from a factor tree of this and this, but eventually you would get to 12 and 12, which then step 3 would be the rewrite step. So we would write 9p squared plus 12p plus 12p plus 16, right? This was my old 24p. I crossed that off and I wrote it as 12 and 12. Then we would group it and we would factor it. So we would take out a 3p and that would leave me with 3p plus 4. Over here, I would take out a 4. That would leave me with 3p plus 4. And I would factor it as 3p plus 4. That one comes out. And then I'm left with the other one, which is also 3p plus 4. And that's why it's a special case, because anytime we have the same 2 things, we write it as 3p plus 4 in parentheses squared. Okay? So it's identical to the other stuff. However, there is a shortcut. So if you're the type of kid that likes shortcuts, if you get to one of these problems and you know that this is a perfect square, meaning I can take the square root of it, and this is a perfect square, meaning I can take the square root of that, you write the 2 numbers down, 3p and 4, okay? So the square root of that is 3p, and the square root of 16 is 4, and you ask yourself if 3 times 4 is 12p, you ask yourself if the middle is double what that is. In this case, it is. So you just put the plus, you put parentheses, you put squared, and you're done. It's the same exact thing as that. Okay, so you have to be good with your perfect squares. You have to know that this is a perfect square, meaning I can take the square root of it. And this is a perfect square, meaning I can take the square root of it. And then you have to double check and make sure that this times this 12p, is equal to 24p. So 2 times this has to equal that middle term of 24p. And if it does, then you can just factor it like this. Okay? And if you weren't sure of it, you could always check your work, right? Which is still quicker than doing it out, because you could just write 3p plus 4. That's what 3p plus 4 squared is. And you could do, okay, there's my 9p squared. There's my 12p. There's my other 12p, which adds to 24p. And there's my 16. So it checks. Okay, so that's special case number 2.